Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting topic in microprocessor, microcontroller and interfacing techniques subject. We're going to see programmable peripheral interface. We will call it as PPI, which is 8255. So in this video we are going to see the functional block diagram of PPI and we're going to see the pin diagram of PPI. Right, so before starting this video I would like to give you the basic introduction about 8255 and then we will see about the functional block diagram. Right, so what is the purpose of 8255? We call it as programmable peripheral interface. What is the importance of programmable peripheral interface? This is basically designed to improve the interface handling capacity of microprocessor. When you take the initial microprocessor of 8085 and 8086 microprocessor, right, it will not be able to, we will not be able to interface many devices with this processors. So what Intel does is, in order to improve the interface handling capability of this microprocessor, we can they have designed this particular programmable peripheral interface 8255. Right, what this IC will do is, with this particular 8255 we can interface many devices with the microprocessor. So that is why 8255 is designed. Right, so in order to improve the number of devices to interface with microprocessor, this is specifically designed. Right, now what is the importance of 8255? How it make many devices interface with the microprocessor, how it is possible? This 8255, for an introduction, it will have 40 pins. It is a 40 pin IC. It is a 40 pin IC, right, and it has three different ports, that is port A, port B and port C. All these are 8-bit ports. When compared to 8255, it is an 8-bit port, and all these 8-bit port are bidirectional. Right, it is bidirectional. What is bidirectional? We can transmit data both from microprocessor and as well as from the interface. Right, so now you could understand what is 8255 is all about. So 8255, what it will do is, if you have any peripheral device like keyboard or any particular device, we can able to interface that with the microprocessor with the help of this 8255. How is it possible? It has different ports, that is port A, port B and port C. Right, through different ports we can able to interface many number of devices, all these three ports. Right, and very importantly, you got to understand the modes of 8255. Right, to start with, I'll just basically tell what are the different modes in 8255. We will see what are the different modes and the complete operation of different modes in different video. Right, but as of now, understand that 8255 works in two different modes. What are the two different modes? It is a BSR mode. It is BSR mode and IO mode, input output mode. This is the two important modes which 8255 supports. Bit set and reset mode. BSR mode is called as bit set reset mode, which is basically to set and reset a particular bit in port C. Right, I'll explain you in detail about BSR mode. Right, but what is BSR mode? It is something called bit set reset mode. Right, if we can able to set or reset a particular bit in port C. And IO mode, right, it is an IO mode. Right, and now you have to understand that we have three different ports, port A, port B and port C, and we have two different modes. One is BSR mode and IO mode, and this IO mode can be of three different modes, that is mode 0, mode 1 and mode 2. Right, so you have to be very clear with this operation. Like in IO mode, you have three different modes: mode 0, mode 1 and mode 2. Now you understand that we have three different ports and two different modes of operation. Alright, and with this basic introduction, we will see the operation of 8255. Right, so remember one particular thing: BSR mode is one particular mode and IO mode is another mode. These are the two different modes which supported by 8255. This IO mode have three different modes, which is mode 0, mode 1 and mode 2, right? So each and every port will work in this different modes, mode 0, mode 1 and mode 2. We will see in depth about all these modes of operation little later, right? So now 8255, as I said, it is a peripheral, programmable peripheral interface, right? And it is designed to interface many peripheral devices with the processors. And as I said, we have port A, port B and port C, and it is a 40-pin IC, as I said. And these three ports, right, it can be configured in two different modes. One is BSR mode, bit set reset mode. Another one is IO mode, right? And I'll come to the IO modes little later, that what are different ports that work in different IO modes, right? We will come to that little later. But as of now, port A, port B and port C. These are the three different ports, right? And these three different ports we can configure into two different control groups, that is control group A and control group B. So how is that I can able to separate this control group A and control group B? That is, we will see that in the functional block diagram so that you can very clearly understand, right? So this is the functional block diagram of 8255, right? As I said, we have three different ports, port A, port B and port C, right? This port C alone, right, we can able to segregate as lower nibble and upper nibble, right? As I said, all these ports are 8-bit ports. All these ports are 8-bit ports, right? And port C alone, we separate as 4 bits upper nibble and 4 bits lower nibble, right? So why is that we are separating it? Because we can group port A and upper part of port C as group A, and similarly group B and lower nibble, lower part of port C as group B, right? So we have three different ports and two different groups, right? These two groups is combined by, group A is combined by port A and as well as upper part of port C, and group B is found by port B and as well as lower part of port C, right? And apart from it, we know that it supports different modes of operation, but different modes of operation will be selected. How different modes of operation will be selected? It will be based upon this read-write control logic, right? The very important part in 8255 is this read-write control logic, right? So when it comes to read-write control logic, you have all these terminals, right? You have read terminal, write terminal, A1, A0 and reset, and as well as chip select, right? And you can see read write is nothing but RD bar, and as well as WR is nothing but write bar, right? You know that whenever we have bar, right, this signal, this particular port can be activated, this particular pin can be activated by low signal by giving 0. If it is 0, then we can able to enable that, and if it is 1, it is not enabled, right? So we need a active low signal to enable this particular read and write. And similarly, the chip select is also selected, that is, if this pin chip select will be selected if it is 0, that is, if it is active 0, then this particular chipset will be selected. 8255 chip select will be done, right? So we will explain this terminals one by one, right? And apart from this read write logic, we have data bus buffer. What is data bus buffer, right? We know that we have different groups here, right? So we have to send data, right? The data can be sent from the data bus to this particular ports through this particular data bus buffer. And this data bus buffer is bidirectional, that is, it is an 8-bit and it is a bidirectional. What is in bidirectional? We can able to send data from 8255 to the microprocessor, and we can able to receive data from microprocessor to 8255. That is why it is bidirectional, right? And from this data bus buffer, we can send data to different ports, port A, port B and port C, right? And coming to this read-write control logic, I have already said how to enable this read-write signals, right? This read-write, this particular terminal is connected to the read terminal of the 8085 microprocessor, and similarly the write pin, it will be connected to the 8085 write pin, right? But it is based upon the working, how the 8085 and 8255 is combined, how it is interfaced, right? Say for example, if it is interfaced using memory, right, then this RD will be interfaced with memory mapped IO, right, of 8085. And similarly, if it is IO mapped, then this will be connected to the IO mapped IO of read pin of 8085, right? So it's depending upon how it is interfaced, whether it interface with memory mapped IO or IO mapped IO, right? So, and then we have two different pins, one is A0 and A1. What is A0, A1? This A0, A1 is used to select different ports, right? Which port, whether it selects port A or port B or port C, it is determined by these two pins, A0 and A1. And also, this A0, A1 selects the control word. What is control word? The control word register. If this A0, A1 is 11, then it will select the control word register. That control word register will tell you in which particular mode this ports will work, right? I repeat this once again. This A0, A1 is used to select the ports. Which port we have to select? Port A, port B or port C, right? And it will also select the control word register, right? So these ports will be selected based upon A0, A1, right? But the modes of operation of these ports, whether it is working in mode 1, mode 2 or mode 0, it will be determined by the control word register, right? So how the control word register will be configured, right? The control word register can be configured in this particular pin, the D0 to D7, right? So based upon this configuration, it will make these ports to work in different modes of operation, right? We will see in depth about these modes of operation and configuration in next video, right? But as of now, this is the architecture of 8255, where I have explained about these different ports and as well as data bus buffer and read write control logic. And very importantly, as I said, we have group A control and group B control, right? This group A control, group B control will get the control signal from this particular control word, right? And this control signal will be sent to this particular groups, right? Group A or group B, depending upon the control signals, right? And as I said, these ports are input output ports, all are bidirectional ports. You can see that all are bidirectional ports, right? Only one particular thing you have to be remember, that port C is divided into two parts, that is upper nibble and lower nibble. Upper nibble is connected with this port A so that it forms a group A, and similarly lower nibble is connected with port B so that it forms group B, right? So this is the architecture of 8255, and you can see how the port is selected based upon the A0 and A1, right? Chip select, we know that the chip select, that is the one which selects this particular chip, right? 8255, and this 8255 chip will be selected only if it has active low signal. If it has active high signal, if it is 1, then it is not selected, right? So this 8255 works only if CS is 0, right? And if A0 and A1 is 00, then port A is selected. And if it is 01, port B is selected. And if it is 10, then port C is selected. And if it is 11, then control register is selected, right? And these are the address location of the corresponding ports, right? So this is the complete architecture and how the ports will be selected based upon the A0 and A1, right? And coming to pin diagram of 8255, I already said we have 40 pins. We don't want to separately study this pin diagram. If you understand the block diagram, you can explain by yourself, right? So if it has 40 pins, we know that port A, port B and port C, right? So port A, port B and port C, as I said, all are bidirectional, right? We can able to use as input output ports, and these are 8-bit ports, as I said, bidirectional 8-bit ports, right? And we have a data bus buffer which is also 8 pins. So if you take 8 pins here, 8 bits, 8 bit, 8 bit, so this will form a 32 bit, right? And then we know that what is the use of A0 and A1? This is another 2 bits, which we'll use to select the ports. And we have another pin which is called chip select, read write, and as well as a reset pin. I forgot to mention about reset pin. You can see here you have a reset pin. This reset pin is also combined with the 8085 reset pin. So we can able to reset 8085 or 8255 using the reset reset pin, right? And now you can see these four forms 32 pin, and this is 2 pin which is 34, and all these 4 pins forms 38 totally, right? 34 plus 4, and the remaining 2 pins are the ground pin and as well as the VCC, right? And you can also explain the reset, RD, write pin, CS pin, and what is the use of A0, A1 pin, as we already explained architecture, right? So today, what we have seen is in this video, we have seen the complete working of 8255. What is the importance of 8255? What is the architecture, the block diagram of 8255? What are the different modes of 8255? In next video, we will see in depth about how different modes work, how we can configure different modes based upon the control word register. Right? I believe this video will be useful for you. Thank you, my dear students.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.